share my screen. Share, and then share screen. So I think it's okay. So let's start from the web page. So I'm gonna follow the agenda from here. And today, first of all, last week we talked about overlay permissive RBAC configurations, and today I'm trying to finish all the agenda, starting from overlay permission RBAC configurations. So let's start from the fourth issue. So basically, it says that RBAC is the primary authorization mechanism. So basically, authentication and authorization is different than each other. So once you, kicked inside the Kubernetes cluster, then depending on your authorization level, you can access the services, you can list the pods, you can delete the pods. If you have permission to, delete the pods, delete the deployments, then you can do that. The most powerful permission is cluster admin, so which means that you can do whatever you want on the Kubernetes cluster. And normally, you should prevent to add cluster admin role to any service account. The reason is that normally I set that service account, but so service account is so that you have a pod, and the pod has permissions to do, let's say that query the API server depending on the cluster role binding or depending on the cluster role, or the role itself. So depending on the cluster role or the role, it can query the pods, it can create the pods, it can delete the pods. So if you set cluster admin, then inside the Kubernetes cluster and inside the pod, then you will have the administrative privileges inside the pod. So some of the, for example, deployments needs that kind of cluster role admin bindings. The reason is, for example, let's talk a little bit about Jenkins. Jenkins needs to create, for example, pods, delete the pods, depending on it is scaling their agents, and it is deploying on other Kubernetes cluster, and also it is it needs to scale its agents. So if there is a remote code execution inside the Jenkins, and by default Jenkins itself deployed as a cluster role with the admin privileges, cluster admin privileges. So if there's a remote code execution, then we can spin up the pod, new malicious pod, and crack the passwords inside the VMs. So let's, you have the Jenkins maybe or other kind of applications, but let's search, for example, one of the favorites, remote code execution, Jenkins, pick it up. So this one. It should be this one, I think. Yeah, that one. So for example, let's assume that my Jenkins plugins has remote code execution. So Jenkins itself has remote code execution. I deploy it on Kubernetes cluster. Then it is very easy to gain access inside the Kubernetes cluster. So you can do whatever you want it. So that's the reason in this documentation, it says that be careful about setting cluster admin roles. So if you are setting the cluster admin role to or if you are assigning the cluster admin role to a pod, then what we should consider the attack surface of that pod. For example, if it's an API and it is published from the external to the public internet, then you will have a problem. Remote code execution is one of the attacks that you can gain access inside the pod, and then you can do your lateral movement. So how to prevent it? So depending on, let's say that depending on the permissions is very important. Limit the access. So basically the what access is needed should be set instead of setting the cluster admin. So you should limit the roles inside the role bindings. So don't just assign any pod query options. Don't assign any deleting or deleting the pods or deleting deployments and kind of stuff, or watching to pods. Just assign what is necessary to your application, and after that, your attack surface will be minimized. And lack of centralized policy enforcement. So it says that in this item, it says that distributing and enforcing security policies across multiple clusters, clouds, and resources quickly becomes unmanageable for security teams. To inability to detect, remediate, and prevent misconfiguration from central location can leave cluster open compromise. So this is one of the very important items in the OWASP Kubernetes top 10. The reason is, for me specifically, the reason is that normally when you install first your Kubernetes cluster, then you start to harden your Kubernetes cluster with the gatekeeper. And in the gatekeeper or Kyverno, you say that, you configure that only allowed repository should be allowed. Only, let's say that my host path should be prevented, and kind of stuff. So you define your policies and you are trying to achieve your compliance level in the Kubernetes cluster. So let's say that for the policies for single Kubernetes cluster, so you're gonna see that, for example, in my repository, I prepared something like this, pod volumes, and it says that who is going to prevent it to do that. So I have a chance to deploy that kind of pod inside my Kubernetes cluster if I'm the cluster admin that I mentioned before, or if I am the administrator of the cluster, or if I have a chance to deploy anything on my namespace. So let's try to deploy it. And the thing is, I can access anything from the operating system level to the etc folder. So if I open my environment, kgpo-a, sk apply-f. So let's deploy this pod, hpo. Go again, okay, describe pod. Let's describe this pod. So it is start and running. So k-exec-it port and --bin -bash or sh. So basically what I have done is I assigned the etc folder of the host path to data folder. So let's go inside the data folder, and I am inside the VM of the operating system. I can do whatever I wanted right now. I can change the SSH folder. I can change the etc passwd. I can change the etc shutdown file, because who am I? This is one of the important comments. So it is nobody, but if I was the root of this container from the user namespace, I can do whatever I wanted to the operating system. So the thing is, for example, who is going to deny or audit that kind of uncompliant pod deployments? So that's why gatekeeper or Kyverno are very important. But the thing is, you don't have only one Kubernetes cluster. You will have, depending on the product, depending on your environment requirements, let's say that test, dev, UAT, pre-prod, prod environments, you will have at least 5 or 6 Kubernetes cluster. And you should centralize the policy management of your environment. So basically, this is one of the things that is important, centralized of this policy. So, I can say that I can protect one cluster with the gatekeeper, but there should be a reporter tool to analyze and then show you the in which cluster I deployed, for example, host path mounting operations. in which Kubernetes cluster and in which namespaces, what are the pods that I deployed as privileged containers. So the thing is, you're going to see that from the central reporting page, the privileged containers that is deployed. So based on that, you're going to audit, or if you want, you can deny it. This item says that, first of all, make a compliance rules of make your Kubernetes cluster clusters to harden and apply your compliances, deploy your gatekeeper policies or key value policies, and after that, centralize that in a reporting page. So other than that, if you don't do that, you're gonna be lost, because every time you should look inside the Kubernetes cluster, click one by one and see that and what's going on to understand it. Or example attack scenario and center is one of the things that we deploy, for example, for uncompliant pods. So let's say that, let's exit. And one of my favorites Kubernetes kubectl plugin tools is Noteshell. So let me show you, for example, how I can gain access inside the VM again by deploying an uncompliant pod into my Kubernetes cluster. So kg-not. So you see that this is one of the VMs that is running K3D, K3S, and k-not-dash shell, the name of the VM. So you see that it deployed a pod on the VM and waiting for my pod to be alive. Unfortunately, I couldn't do that because it is terminated. So let's try again. Whatever. So basically, Noteshell will gain access inside the VM. So I will list the processes I can do, for example, list the processes, touch the operating system file system. I can do whatever I wanted in the VM, because the matter is I deployed an uncompliant pod with privilege, host pet mounting, process namespace, and IPC namespace is shared by deploying this ncenter. And ncenter is the pod that is running with Noteshell. So the fifth one is the logging section. So it says that a Kubernetes environment has the ability to generate logs at a variety of levels from many different components. When logs are not captured, stored, actively monitored, attackers have ability to exploit vulnerabilities while going large undetected. The lack of log monitoring also presents challenging during incident investigation and response efforts. So it says that, first of all, we should do Kubernetes audit logs. So basically, if you think that if you're not auditing your Kubernetes cluster, then you will not have the information of who is doing what operations. And to enable Kubernetes audit logs, you should play around with the API server. And we should enable the audit logging, first of all, while deploying our Kubernetes cluster. So Kubernetes, let's search audit logging. And let's open this one. So audit policy. So basically, audit policy file, this page is very important. The reason is that we should add this parameter to, let me focus, audit policy file to the API server. And after that, our Kubernetes cluster will start to log the, log the who do what operations. So we should first of all add this flag, and after that we should save this file on the operating system, and then our Kubernetes cluster will start to do the audit logging. And after the audit logging started, we should ship these audit logs into centralized logging system like Log Analytics or Elasticsearch or somewhere else. And there are plenty of solutions in the field, you can use it. And if you are, for example, if you are using, or this is for on-premise solutions, but if you're using, for example, AKS audit logging, you should enable and then save it to Log Analytics, Audit Logging. As you can see from the diagnostic settings, learn more. So from the diagnostic settings, if you enable audit logging, for example, in AKS, then you will have the understand that who deleted my pod operations or who created this pod operations. And the matter is, in the next section, we will talk about the authentications of Kubernetes cluster. And in the, for example, in the authentication, it says that if you first of all install Kubernetes cluster, then you will have the cluster admin, because you will have that file, and then you're going to access your Kubernetes cluster with that YAML. I mean, your configuration file as a cluster admin. And as a developer, I need to access the Kubernetes cluster to deploy my applications. Then if you share the kubeconfig file that you have with me, then the problem is the administrator of the Kubernetes cluster and the developer of the Kubernetes cluster will have the same username and password, not the password specifically, but the certificate. And then in the audit logs, we're going to see that cluster admin is creating or deploying the pod or deleting the pod. So in terms of audit logging, yes, it's working, but in terms of actually who is generating a workload or deleting my pods, how can I audit this? So the authenticated user should be logged. So that's why the authentication method and logging is correlated to each other. So after you install your Kubernetes cluster, you can install Keycloak or any other authentication mechanism. I mean, not Keycloak is not an authentication mechanism, but you can do, for example, LDAP integration with Keycloak to your Kubernetes cluster. You can do, for example, Azure Active Directory integration, or you can do OIDC integrations. And after that, after you do your authentication, so you should, I mean, as a best practice, you should enable multi-factor authentication. So if I know your password, then I can crack again, your Kubernetes cluster as a best practice as you do in the cloud vendors. So if you're logging your portal, then most probably all the cloud vendors administrators has the MFA enabled. So again, if you are administrator of your Kubernetes cluster, then you should enable MFA for these accounts. And one of my favorites is actually, if you have any Kubernetes cluster, it really doesn't matter. So we have, I mean, in the Azure Active Directory, let's say that Kubernetes, and in any Kubernetes cluster, you can integrate Azure Active Directory with your Kubernetes cluster. So you enable the Arc agent on your Kubernetes cluster, and after that, you assign a group to do what operations. You create your groups, you assign the groups, you add the users inside the groups, and after that, so you list the operations that the groups can do, and it is very easy to manage through the portal. So which is one of my favorites. So you just spin up your Kubernetes cluster, and then if I'm on-premise site, I enable the Azure Arc, and then enable the Azure Active Directory integration, and assign my users into the groups. I assigned roles to the groups, then everything starts to work. So if somebody signs up from the company, I just remove the user from the group, then it starts to work. So you don't have to, for example, share your kubeconfig files or integrate other places. So it is very easy. And in the Azure Active Directory, it is very easy to enable multi-factor authentication. So it is the management and the operation costs will be reduced by this integration, and I really like that integration for authentication and auditing. So network segmentation. The network segmentation is actually, of course, the network policies. So network policies is, let's say that port A, I have a port A and I have a port B, and I don't want port A to talk with port B, as I don't want to create any connection to the port B. Only, let's say that port B can communicate to port A. So I have a chance. I want to, for example, prevent ingoing and outgoing. I want to prevent outgoing connections to port B from port A, and I want to only allow port B to access port A. So this is where network policies kicks in. It's you can think like a firewall inside Kubernetes cluster. And Ahmed has very good explanations on network policies. And if you Kubernetes repositories, it should be in here. Network policies receipts. And if you open that, for example, one of the network policies, he is in his GitHub. Let me open this one. Yeah, I want to see any picture of him. Create combined. I couldn't find it. Deny. Yeah. So denial traffic to an application. So basically, with that network policy, you apply this network policy and pod selector app. If the pod has the web labels, it's not going to accept any traffic. So it is ingress. So basically, the ingress rules are prevented, but on the other hand, the outgoing processes, the outgoing connections will be available for this pod. So network policies is applicable for your we can say that microsegmentation inside your Kubernetes cluster. So normally, if you deploy something on your Kubernetes cluster, every pod can communicate with each other. So if you want to harden your Kubernetes cluster and do your segmentation, network policies kicks in. And all of the Cni plugins doesn't. Cni doesn't support it. So if you have the Flannel Cni, then you should install Calico on top of it, or other network policy plugins on top of it. But if you have the Calico, then Calico Cni and the Calico network policy is, of course, is tightly integrated with each other. You can continue with that. So let's open, for example, CNCF landscape and then see the path CNCF landscape and then see the Cni plugins for this. And cloud native network, this part is important. Let's focus on that. Yeah. So while selecting the network policy, the Cni plugins are important. So for example, Cilium supports it, Calico supports it, NS60 supports it. Flannel doesn't support network policy. That's why you should install, if you have this Flannel, you can install Calico policies. The plugin of the network policy plugin on top of Flannel, and then you can continue. So if you want to apply the network policy, Cni plugins are very important. And let's go back and then secrets management. So normally, if you have the secrets, then it's very easy to, because it is very easy to decode the base 64. You just copy the secret and then you go to, for example, base 64 decoder. If I can list the secrets, then it's very easy to decode the secrets. So as you can see, I can do it. So if you don't have to be the administrator of your Kubernetes cluster. It is really easy to list these secrets. If you have a permission to list the secrets, then I'll copy the secret output, and then I will not decode the secret. So I will get the password or whatever your private string is. So instead of that, we can use secret store for this. So let's say that, I mean, I want to mount the secret from a key vault system, or I want to mount my secret to the environment variable, but I don't want Kubernetes to manage the secrets. I need a key vault system for this. So that's why there are some sort of CSI drivers. And Azure CSI driver key vault is one of the things that I use it. Azure Key Vault provider. So basically, you store your secrets inside the Key Vault with this CSI driver. If you need an environment variable, or if you want to mount the certificates or your connection strings, you put it the Key Vault, and then with the CSI driver, you mount it. So if you have a permission to list the secrets, there will be no secrets. The CSI driver will handle that information. So these are the secrets related issues. So first of all, if you let's say that, okay, you are not going to use HashiCorp, you're not going to use Azure Key Vault. So let's search for another tool. I can go HashiCorp CSI driver. So search for Vault CSI driver, and then I can install, and then I can put my secrets inside the Vault, and I'll do the same operations that I showed you just seconds ago, the same things. So the thing is, don't put your private strings or your secrets, your connection strings, whatever you have in the secrets. Just use Key Vault CSI driver or your Key Vault CSI drivers. So if you want to use HashiCorp, you can use it. Conjure is one of the tools that you can use it, or you can use the Azure Key Vault system, and after that, you're going to use the CSI driver for this. Basically, don't put anything inside the Kubernetes cluster as a secret. The other one is the misconfigured cluster components. The misconfigured cluster components is one of the things that, I mean, if you're not spinning up a managed Kubernetes cluster, then if you're building your own Kubernetes cluster, either in the cloud vendor or in the on-premise, so be careful about these parameters, because the API servers, if the API server has anonymous authentication, or if you are not set up the SSL certificates, then I can access your Kubernetes cluster very easily. I can do whatever I wanted. The other one is if you don't set up the SSL certificates, because Kubernetes can communicate with the clear text if you don't set up the SSL certificates. So it is very easy to do that. So these are the two good practices. Don't put this parameter inside the API server, and don't put always allow. It should be webhook, and anonymous authentication should be false to protect your Kubernetes cluster. I mean, it is for on-premise Kubernetes clusters installation, not for the vendor, cloud vendors Kubernetes cluster, because normally it doesn't allow that kind of things. And the other one is vulnerable components. So it says that you install your Kubernetes cluster and start to deploy your infrastructure-related components. One can be Nginx, the other one is Argo CD, the other one is Istio or Linkerd, whatever you have is. Be careful about what you deployed on your clusters. And because of this CVE records, we can access your Kubernetes cluster if you think as a bad guy. For me, we can access your Kubernetes clusters, the bad guy side. So let's say that Ingress Nginx controller is one of my favorites. Again, for example, Nginx Ingress CVE records. Let's look at these ones. Kubernetes CVE vulnerabilities. Let's get the Nginx Ingress CVE vulnerabilities. No. Let me go back. At least not the remote code. Security vulnerability, this one, directive injection via annotation. So for example, because of this CVE, you will have the vulnerability inside the Kubernetes cluster. So you should scan what you're deploying on your clusters, and time to time you should check what the vulnerabilities you have inside your clusters to protect your clusters. Because if there's again, this is not too high severity level, but if you have the remote code execution, then you will have really good problems. So you should protect your cluster, and you should scan your deployment, your images, your Kubernetes components, and you should upgrade your Kubernetes cluster at least once in 3 months to catch the latest version, because every version has some sort of vulnerabilities, and if the vulnerability is a critical vulnerability, you will be affected. So if you upgrade it, so at least you're gonna protect your cluster from the Kubernetes components. But the components you are deploying on the cluster is another topic. So the thing is, scan your images, what you're deploying. If you have the vulnerability, critical level vulnerabilities, understand that if you are affected or not. So if you're affected, even if you're not affected, and if it is compatible, it has a compatible level of your applications, because sometimes components are not compatible with each other, upgrade to the latest version. So upload your CV vulnerabilities in a centralized vulnerability management system. Scan your, again, system by this way. So there are plenty of amount of tools. Azure Defender for Containers is one of them. SIFT is one of them. Or let's say that Trivi is one of the tools that I use, again, to scan your images. So basically, you will have the vulnerabilities of the components by this way. So overall, we talk about the 10 important things. Insecure workload configuration. Don't deploy anything that has the vulnerability. Supply chain vulnerabilities inside the containers there may have the packages, and then you should extract your SBOM file and then upload it. Try to understand what vulnerabilities you have inside the containers. And RBAC permissions, don't don't assign pods or your users more than it's needed. And overlay policy enforcement, centralize your policy management, define your compliance level, and then deploy your gatekeeper or key vendor policies and centralize that policy deployment and auditing. Try to upload or try to ship your audit logs to Elasticsearch or Log Analytics or whatever your log solution is, and then on top of it, you can analyze and you can install anomaly detection tools to understand that if there's an abnormal delete operation, abnormal pod deployments. Broken authentication. So at least for the cluster admins, you should enable multi-factor authentication inside Kubernetes cluster. Azure Arc is one of them, or you can enable, you can install Keycloak for this one. Network segmentation, pod-to-pod communication should be restricted with the network policies. Cni plugins are important for this. Secret management, if it is not necessary, don't deploy secrets. Instead of that, use Key Vault CSI drivers. It can be Azure Key Vault CSI driver. It can be HashiCorp Key Vault CSI driver. Misconfigured clusters. So be aware that the API parameters and anonymous authentication for on-premise or manual Kubernetes cluster installation, it is not applicable for the Kubernetes cluster that you are deploying on Amazon, Azure, or Google Cloud. These parameters cannot be added or removed. Vulnerable components, scan your, whatever you're deploying inside the Kubernetes cluster, scan your images, scan the Istio, the Argo CD, Jenkins, whatever you're deploying, scan your whatever the the images that you are deploying and try to upload to the latest version. And these are the other risks coming soon. There's no risks. I mean, there are lots of risks, but these are the top 10 for the OWASP one. So let's look at it if there's any question, so we can close this meeting. 2 comments. Be great. Can you mount multi-key vaults and mount them in different namespaces? Never tried it, but I think I can do it. Yes, it's applicable. I think I should try it. Because there's a way to install multiple key vaults, and I think we can do it. I should try it. Normally, we just choose one of them. Thank you so much. If there's no other question, we can close the session. Thank you so much for attending our session. Have a good day. Next week, I'm going to talk about SBOM and OWASP dependency track. Thank you. Have a good day.